It's important to note that anytime we are dealing with rates, we are talking about how quickly something happens during a given reaction. Now, one important concept we need to cover when it comes to reaction rates is the concept of half-life. Half-life describes the amount of time it takes for a substance to half its original concentration value. So if we were to have 20 molar of a given substance, half-life would describe the amount of time it takes in order to see 10 molar of that substance remaining. Let's call the half-life for this substance 10 seconds. So this is the half-life for this substance. So it's important to note that this half-life will stay constant. So if we were to run this reaction for another 10 seconds, we would see half the original value. So half of 10 is 5 molar. If we were to do this one more time, we would see 10 seconds go by to see 2.5 molar remaining. So as we can see, the amount of time stays constant between each half the original amount of that concentration. So 20 molar went to 10, went to 5, went to 2.5, and would continue to half and continue to stay 10 seconds in those intervals in which this concentration will have its original value. So what if we are met with a problem like this? It says substance X has a half-life of 3 days. So what we can see is every 3 days, we will see substance X half its original value. So an experiment was run with substance X in which 4 molar of substance X was remaining after 12 days. How much of substance X was there at the start of the experiment? So we are seemingly dealing with a timeline in which this is the start of the experiment and this is 12 days later. Now it is asking us to calculate how much of substance X we had at the start of this experiment. However, we know that 4 molar was remaining at the end of the 12 days. One important information that we need to take into account when we answer this question is that the half-life is 3 days. So what we can do is count by 3 days. So from the start of the experiment, at 3 days, we know in this amount of time that this concentration will be half. What we also know is that at 6 days, which is another 3 days, once more, we will see the concentration half again. Then at 9 days, we will see another half. And then at 12 days, we will see half again. So when solving problems like these with a lot of words in a paragraph, I really suggest drawing out a picture or a diagram so you can visualize what's going on. At this point, I have a much better idea of how I can solve this problem than just trying to see without a picture. So what we can do is say at 12 days, we had 4 molar. Well, we know from 9 days to 12 days, 3 days went by, and we know that the half-life is 3 days. That means at 9 days, we must have had a concentration of 8 molar. That's because when 3 days went by, we must have halved our concentration of 8 molar to 4 molar. So it's almost like working backwards where now we have to double it. So we know at 6 days, from 6 days to 9 days, 3 more days went by. So we will see 16 molar at day 6. Then what we can see at day 3, this would be 32 molar. And then at the start of this experiment, that means that we must have had 64 molar. How we solved this problem was drawing a diagram and noticing that the half-life was 3 days, knowing that at the end we had 4 molar. So working backwards, every 3 days, we can double that concentration. Now looking at it from left to right, we can see that every 3 days we halved our value from 64 to 32 to 16 to 8 and then to 4. So Solving a problem like this is definitely something that's super important, and it works on your problem solving skills, drawing a diagram, and being able to think through a problem all the way to the end.